Hi, everyone. My name is Ronit Margulies, and I'm the Director of Corporate Communications at Brisometer, and I will be your host and moderator for today's webinar. I just wanted to go over a few housekeeping items before we get started. The webinar will be recorded, and a copy will be sent to you tomorrow. And yes, we will be holding a Q&A session at the end of the webinar, but feel free to send in your questions via the Q&A button over there, because I guarantee that you'll have questions. And if we don't field those questions in the course of the webinar, someone will follow up with you afterwards. So today's webinar, I want to be honest with you guys before we get started. We had a bunch of different names for this webinar: the science behind wildfire monitoring technology, how businesses can deal with air quality reporting challenges, etc. And they're all true, but none of them fully encompass the magnitude of the worsening situation and some of the technology that's being built to tackle these wildfire monitoring challenges. So I'll say it like this. We've been asking ourselves the hard questions about wildfires and their spread and how they affect the air quality of millions. We've also been asked all the hard questions about what's out there and how it can be done. And we thought, well, isn't this a timely opportunity to share all of our answers with you and the world? But you guys all registered, so lucky you. So this is that time in the webinar where I introduce you to our expert, Yvonne Bouzet. Yvonne is an atmospheric physicist. She has about 16 years of experience in scientific research, a PhD from ETH Zurich in Switzerland, where she was actually awarded for her PhD thesis as amongst the best 8% in that year. During her PhD, she participated in several international research campaigns in multiple countries, amongst them a large campaign in, yes, California and Washington that involved 4 research aircraft and research vessel, and was investigating how pollution particles from the Central Valley affect extreme weather conditions like heavy rainfall or drought conditions. I think we might have brought you guys the right expert here. Before joining Brisometer, Yvonne spent a month in the high Arctic, where she and her colleagues investigated the reasons for the extreme effects of climate change in the region of the world. Did I tell you we brought you the right expert? And things you didn't know about her: she loves running and hiking in the mountains and wood. But back to what we're talking about today. Yvonne, could you tell us a little bit about what you do at Brisometer?
Hey, Ronit. Yeah, sure. But first of all, thanks a lot for this very warm introduction. I'm very happy to be with you here today. So at Brisometer, my role is to deliver and ensure the scientific soundness, basically, of everything we do. For example, I work very closely with our highly skilled and team of environmental scientists, of algorithm engineer, of data scientists, to develop and continuously improve our air quality and our fire models. And I basically keep my eyes open to what's going on in the world of research and to what colleagues of mine in the academic world do and what we can learn from them.
Awesome. We're super happy to have you here, Yvonne. And let's get started. So let's start with the obvious. I mean, the question's, sitting up there in our face. So why are we talking about wildfires, and why now? So peruse the headlines, folks. I know it's harsh. It's meant to be, because the effects of worsening wildfires are being felt globally, and the devastating impact is just getting worse. And these are headlines just from the past week, just so you understand the situation. But to many of you, it's not new news. And but what you may not know is the total cost at hand of these worsening wildfires, and most likely it's greater than you think. According to the National Fire Protection Association, in California alone, the 2020 wildfire season had, as of mid-October, killed more than 30 people, destroyed some 8,500 structures, and torched a record-breaking 4 million acres of land, doubling the acreage burnt in 2018. But loss of life and property, devastating. They're devastating, but those are the obvious costs that you think of, but they're not the only ones. According to Reuters, Western US wildfires cost insurers up to $13 billion in 2020. This has caused an insurance crisis like we haven't seen, where insurers are refusing homeowners insurance in specific areas out of fear of further loss. Not to mention the incurring costs for containing harder to contain wildfires. According to the data from National Interagency Fire Center, federal wildfire suppression costs in the United States have spiked from an annual average of about $425 million from 1985 to 1999 to $1.6 billion from 2000 to 2019.
That's a lot of costs on it, but unfortunately, that's not all we need to consider when we speak about wildfires. There are additional costs that are related to long and short-term effects of the air pollution that originates from wildfires. Wildfires create a toxic mix of pollution that appears as smoke and as ash, and they really pollute the air that we breathe, but they also pollute the soil and water. And the effects of the air pollution on the health of people is both short-term. It causes irritation of the nostrils. It give you a feeling of feeling sick, like that your nose is running, that your airways are irritated. But there are also long-term effects, and they're even harsher. They can cause all kinds of respiratory illnesses, including asthma and pneumonia. And the related healthcare costs that have been caused by US American wildfires between 2008 and 2012 have been estimated by the EPA, the Environmental Protection Agency, in 2017 to $63 billion for the short-term exposure, which can lead to premature deaths or hospital admissions. But the cost of the long-term exposure was even higher. It was estimated to about 450 billion US dollars. So let me show you what I mean with these air pollution effects of wildfire. What you see here is the air quality in the area around the Beckworth complex fire that has been burning around the Nevada state line and is currently the largest wildfire burning in the US. This year. What you see, these deep purple and red areas are the areas right next to the fire perimeter itself, or at the fire perimeter. And here we're measuring the poorest of air quality in the vicinity of the fire. But if you look at the surrounding area, you see that this wildfire smoke is traveling super fast. It's changing its direction super fast. So it's impacting in a very dynamic way the air quality in around the wildfire and further apart. And if we go to the next slide and zoom out a bit from this area, so now we see the most of the Western US, we see that the air quality in this entire area is affected by fires burning close to you, but also quite far. And in fact, in 2020, the fire smoke from the fires that were burning in California and Oregon affected the air quality all the way to on the East Coast of the United States. And there are also several cases where North American wildfire smoke has been detected and has affected the air quality even in Europe. And we have a real world life example from our colleague Marcos, who is located in Utah, who felt pretty sick the last days because he had to breathe this heavy smoke that got to him from the fires on the West Coast.
Those are some harsh realities, Yvonne.
Yeah, definitely they are. And I mean, to me, it's a reminder that we really need to understand the full environmental picture and keep it in mind when it comes to safeguarding humans and property.
And in that light, maybe we should better understand the science behind the wildfires themselves, what causes them and why they are getting worse.
Yeah, let's start really basic. So from chemistry class, maybe some of you remember that in order to get a fire started, 3 things are necessary: fuel, oxygen, and heat. Now, fuel in the case of wildfires can be live or dead trees or grass or brushes, basically all kind of vegetation and or other organic matter. Oxygen, well, there's a lot of that in the air around us. And then the spark finally that ignites the fire. Now, this spark can originate mainly from human errors. So a typical example is a campfire that wasn't put out correctly, but also a cigarette or even trash that is thrown in the wrong place and now together with the sun acts like a lighter. But it can also come from overground utility power lines that are either knocked off by a storm or that were not taken care of enough and are not fully insulated. But also fireworks can light wildfires. And actually there has been a study that came out last year that quantified the role of humans that played a role in creating wildfires that actually threaten residential homes. And this has been quantified to 97%. So in 97% of the wildfires that are threatening properties, residential homes, they are caused by humans themselves. Now, another big natural factor that can also light wildfires are lightning strikes. And actually some of the fires burning right now in California have been lit by lightning strikes. And finally, unfortunately, this extreme heat that we've seen now in Canada and in the US, that it by itself is a risk for ignition simply because it makes spontaneous combustion of dried out vegetation much more likely. So that's what it needs to get a fire get started with burning. However, in order for a fire to continue burning and to spread and to move, it again needs mainly fuel and in addition the right weather and climate conditions. And hereby, the drier the fuel, the more easy it is for the fire to consume that vegetation and to spread and move. And so this is why traditionally fire season occurred mainly in the end of the summer or early fall, as then the warm temperature and the dryness of the summer led to the vegetation being dried out. And in a drought, however, as we're experiencing again this year and have been in the last decade over and over, this can happen much earlier in the year. And as we've seen this year, fire season started super early. And in addition to droughts, also certain diseases and certain bugs, like the mountain pine beetle, for example, can cause an entire forest to weaken and to die off. And died off vegetation is again very dry and can be a much easier food for a wildfire and thus cause a wildfire to spread.
That's new information for me, Yvonne. So we've reviewed the causes and the spread. Let's take a look at the worsening. As you can see in this chart from the New York Times, it shows the steep increase in active fires over the years, and they are certainly getting larger, and that's for sure. In fact, 6 of California's largest fires in history ignited in 2020, not to mention the one that already is burning right now, and the damage and toxic smoke exposure extended far beyond state lines, as Yvonne mentioned earlier. And it wasn't unique to the US last season or this one. And speaking about seasons, this is interesting. I read somewhere that in the 90s, there was actually what you can call a season of a few months of wildfires. And it must have something to do with what you mentioned, Yvonne, about the summer small drought. But now it's up to something like 7, if not more months out of the year, 7 months. That's longer than any season that I know. And in fact, I read, and that's probably the same article, that many of the firefighters are not relating to the word fire seasons anymore. It's fire years. They're planning to handle fires all year round. So seasons are even becoming a thing of the past. And I mean, look, we're only in early summer, and the Beckworth Complex fire is raging along the Nevada state line. It's become the largest in Northern California, which were born of lightning caused blazes, like Yvonne mentioned. And by this past Monday, had it already consumed around 90,000 acres. Not only that, the European Commission is issuing fire prevention orders for what is estimated to become the busiest fire season to date. And recently, a Cyprus wildfire labeled the most destructive in the island's history claimed over 12,000 acres of forest mere days after starting. Not to mention the worsening droughts conditions, which Vaughn mentioned, which has an effect on wildfire probability. So the question we have to pose, and yeah, it's obvious to some, controversial maybe to others, is climate change an impetus for the worsening wild seasons?
Well, yeah, definitely. Nowadays, there is virtually no doubt that climate change plays a key role in the increasing number of wildfire, their increasing size, and the increasing length of the fire season. Just as you said, by looking at the last decades, we see that all of these factors trend upwards, and also does the number of droughts. So climate change comes in here in multiple ways, in several aspects. Overall, as most of you probably know, climate change leads to rising temperatures worldwide, but it also makes extreme weather conditions much more likely. And these extreme weather conditions can be heat waves or droughts, but by the way, also very cold conditions or even heavy floods, but that's not for now. So heat waves and droughts get more likely. And if you think of it like a half a degree increase in global average temperature, if you imagine that on a single day, it might not seem like that much. However, unfortunately, half a degree increase in global temperature means that the probability of extremely hot days increases per year tremendously. And that's what we see in this year, also in Canada and the US, and also other places, Siberia, Cyprus. But what we see now this year in Canada was what people call a heat dome. Now, the underlying weather situation for that heat dome is not necessarily directly related to climate change. Research says that such a heat dome is most likely to occur in what is called a La Nina year. And that means basically that the sea temperatures of the Pacific, of the Western Pacific, are warmer than they are in the Eastern Pacific. And I don't want to get into the details of such a La Nina year, but what that means is that there is warm air pushed from the Pacific towards the west coast of the US, or the entire North America. Now, this hot air then gets trapped in the Western US and Canada, and it really is parked there. And now a kind of a vicious circle starts, because this dry, hot air takes off a lot of humidity. So it basically works like a sponge. It sucks out the humidity from the vegetation. And as the vegetation dries out more and more, it loses more and more of its role of cooling, because less and less evaporation is happening, and evaporation has a cooling effect. Now, that means that once this evaporation has decreased, it just gets hotter and hotter and hotter. And this is what we've seen now in the US and Canada, but as I said, also in other places. And unfortunately, this is not the only effect that climate change has. As I mentioned before, lightning strikes are, apart from the human errors, human activities, a main cause that ignites wildfires. And these thunderstorms also get more likely, and they get bigger and more intense due to a warmer climate. There is more energy in the air that leads to more intense thunderstorms. And then there is a third aspect that climate change brings to the table in the case of wildfires, and this is the changing patterns of snow and rainfall. And this impacts the season of the wildfire. This is why the season gets longer, because the onset of rainfall and snowfall in late fall or winter is what usually naturally ends the wildfire season. Now, if that gets delayed and there's less rain and snow falling, then also the fire season gets extended and fires have more time to spread and generally to ignite. And the same is true for the spring. If there is less rainfall and snowfall during the winter, the forest can store less humidity and water over the winter, so it already starts drier into the spring. And now through the warming temperatures in spring, it gets dried out earlier, and this makes the fire season start earlier potentially. Now, I spoke about lightning becoming more frequent due to climate change. And in this respect, I want to mention the study that I came across recently because I think it's pretty cool. That's from scientists at the MIT. And they found out that wildfires can actually create their own lightning strikes, which then in turn create more wildfires. Ronit, do you have any clue how a fire can create its own lightning strikes?
Not a clue, not at all.
Well, you're not alone. Also, scientists have been wondering about that for the last decades. This is what is so cool about this study, that the team at MIT apparently figured it out. And what they realized is that it's air pollution. It's the air pollution, so the fire smoke that is created by the fire, that consists of a lot of very small particles, and these particles get sucked into into clouds, into storm clouds. And here they now provide a surface for tiny, tiny ice crystals to be created on them, to form on them. And now what you need to know is that when ice crystals of different sizes, as you have in such a cloud, if they collide with each other, then this creates a charge, an electric charge, and this can lead to lightning. I think that's super cool, but maybe I'm a bit of a nerd when it comes to fires and air pollution and clouds and all that.
Well, then maybe I'm just a bit of a nerd. So why are wildfires one of the most challenging environmental hazards to track? And just for credit, guys, the video is a preview reel that I'm playing now of a film made by artist Jeff Frost showing the effects of climate change on extreme environmental events. I thought it would be a good backdrop for what Yvonne is about to tell you. So enjoy.
Yeah, so that's a really good question, why wildfires are one of the most challenging environmental hazards to track. And let's go step by step while watching this, I think, beautiful, even though a pretty sad video. So what you need to predict the risk of igniting a fire is that we need to know the weather conditions, so mainly humidity and temperature. And that is actually pretty easy comparably. But in the end, to forecast the spark that lights a fire or not is more difficult, because most of the time it's from humans, and humans are pretty hard to predict their behavior sometimes. And the same for lightning strikes. I mean, you can to some degree predict that there is a thunderstorm coming. However, where exactly a lightning strike will hit is very, very difficult. And then, so this is now when you have a fire, how to get to a fire, but then on how to predict how the fire is spreading, you need to know the fuel availability. This determines the speed and the direction also to some degree in which the fire is moving. Now that fuel is basically how much biomass, so how much dry and old branches lie in a forest and haven't been cleaned up. And this is difficult to determine precisely, as you can imagine, especially in large remote areas. And then a very influential factor is the wind. And the wind changes on all scales, on temporal scales, from the second to hours to days, but also on the spatial scale, so on centimeters to miles. And the fire forecast model until recently only took one wind direction and one speed into account, which is pretty crude. Especially when you think about that, as you see in that video, there's loads of energy in the air, which leads to a very dynamic system of air movement around the fire. And then there are additional factors like the terrain and the vegetation that speed up or slow down the fire. And one fun fact to know is that in I think northern Australia, there is also a type of bird that likes to pick up burning branches and transport them further away from the fire. And unfortunately, then these fires, of course, then these burning branches also ignite other fires. And actually, wind also plays a major role in the transport of fire smoke and ash and how air pollution affects people. Now, surely there is a lot of very toxic smoke around wildfire, as you can see in this video, but the wind also transports this fire smoke to areas further away from the fire, as we saw in the heat map video earlier. And as I mentioned before, and I think it also applies here, when monitoring these environmental hazards of air pollution, of fire, we really must consider the whole picture, which is difficult to achieve, as I think I've described. But I don't want to be negative here, Unit, don't worry. I'm getting to that, how to do that very soon.
That's great, Yvonne. We can't just give them a cliffhanger and run off. So maybe we should start with what exists now and the limitations that exist, if any.
Yeah, definitely. So when it comes to fire monitoring for any purpose, may it be protection services, helping people to avoid areas of polluted air or avoiding areas where fires are burning, if you work for a utility service, an insurance company, or in logistics, or if you just live in an affected area, you're going to seek out information about the fire movement and how it is affecting the air that you're breathing, or in some cases also how it is affecting your business. So let me start with what exists for information about fires currently and why they are often limited in the insights they provide. So there are many services that are free to the public that can provide helpful information in specific situations. Mostly these sources are governmental sources and data. However, as you can see in this picture here, these, especially monitoring stations, are often scattered in space and in time. So in this example here, which I think it illustrates it very nicely, there are several monitoring stations. However, none of them detects the fire that is actually very close by, simply because they're upwind of the fire. So the smoke just doesn't get to that station, even though a very large area is already polluted by the fire smoke. And even if you have, if the fire smoke gets to the station location, if that station now doesn't measure the pollutant that indicates that there is a fire, mainly particulate matter smaller than 2.5 micrometer, then it simply doesn't help you, it doesn't indicate you that there is a fire if it measures other pollutants that are not related to wildfires. So when you're talking about wildfires and when it comes to the exact location and showing the perimeter of the fire, many data sources are also delayed in reporting. Now, as you can imagine, real-time information is crucial for your safety when you are directly affected by a wildfire, but also for businesses that are affected by them in order to plan and react accordingly. So there are also sources that rely solely on one technology for monitoring, both in the field of air pollution caused by wildfires, but also for the fires themselves. And relying only on one source of information can easily lead to false positives. So you can detect air pollution that isn't there just because you have some erroneous data, or you might report a fire that isn't there because something went wrong with your observations. But maybe even worse is when you're missing out on fire, or when you're not reporting the air pollution that is out there. And then, of course, if you are relying on ground measurements, these ground measurement stations can fail, especially in the case of wildfires. They might have a power cut because the utility line was cut by the fire, or the station itself was burned, or there is no connection anymore that brings the information to the servers. And then, of course, as I mentioned, all kinds of data can have delay, even satellites, which might see the fire. They might not see it because they're clouds, but they also might have delay until detecting a fire or its smoke. Thus, the more data you have, the more accurate and timely is your reporting on air quality and on wildfires. And this is often missing in the information out there.
Which certainly complicates the public concern, especially in light of the worsening events year after year. So I wonder, and then if you can tell us, what is necessary to provide accurate and reliable information for monitoring fire behavior and its effect on our health?
Yeah, sure. However, for full disclosure to the audience, I'm going to talk a bit more on what we're doing at Brisometer as we build our technology and continue to improve on it in order to meet the limitations of what is available to the public. So we saw what is missing out there in the available information. And our approach at Brisometer is really to make use of all the available data sources out there. So we take into account ground measurements. We use 49,000 governmental stations worldwide. And in addition to that, we use low-cost sensors. And we add to that satellite observations from multiple spaceborne platforms. We then use a range of models, atmospheric models, atmospheric chemistry models also, and we add to those also machine learning algorithms, and then combine it with official governmental information, which together provides us a full set of data on fires and air pollution. But that is not enough, as we know and discussed earlier, when it comes to those changing patterns, especially related to wind and the environmental effect that affect the fire spread, the fire movement, the behavior of the smoke. So we also take into account meteorological data and terrain and land cover information. And what's particularly important to us at Brisometer is a continuous check of our accuracy. We validate ourselves to observational data wherever and whenever available, and keep on improving our algorithms and methods and reevaluate the data and methods that we use. And personally, I think this is critical when we're talking about staying safe in the face of wildfires, which I think is one of the most harmful phenomena that we're facing right now as humanity, simply because they spread so quickly and are seemingly impossible to avoid. We also found that providing a visualization of the behavior of these fires and smoke and other air pollution events make it easier to understand the location of the fires, the dynamic behavior of those fires, and the related air pollution in order to take action accordingly. And one example of this are the heat maps that I showed you earlier, and also alerts related to these fires.
And really, that's also the bigger issue here too, Yvonne, that people need data that they can rely on in unsafe and dire situations. And also to know how to make actionable decisions to protect their health and the health of their loved ones. But guys, we can go on about our technology all day, as you can imagine, but we're coming to that time, and we already had some interesting questions that were sent in, and we want to be able to field some. We would really be happy to do a part 2 of where we can get more into the technology behind our fire products. Just let us know that this is what you want to hear, and really any topic that you guys want to hear, and let us know. So if that wasn't clear, this is the time, guys, when you send in your questions. Don't be shy. Anything that comes to mind, we'd really be happy to hear it. And Yvonne, I'm gonna get started because we've already got some questions coming in. First one. Are there differences in the pollutant release from different fires, i.e. trees, bushes, etc.?
That's an interesting one. So generally, fires emit a lot of CO2 and water vapor. And then in addition to that, there can be lower concentrations of carbon monoxide, and that's why fire smoke is so harmful, but also from aldehyde, benzene, and all kind of polyaromatic hydrocarbons. So the exact composition of the fire smoke, that depends on several factors. One of them is the fuel. So is it trees? Is it bushes? Is it grass? Is it the bushfire in Australia or forest fire in Canada? But it also depends on the humidity of the air and of the vegetation that was burned, and also the temperature at which the fire was burning. And then, of course, you can imagine when the fire is getting to residential areas, then you have all kinds of things burning, and that you also find in the chemical composition of the wildfire smoke.
Cool. I'm going to give you another one. Are you ready?
Sure.
How do you avoid false positive in fires caused by plant oil fields?
So generally what is done, so I think this refers to satellite observations, and what is done by the satellite data providers such as NASA and NOAA. They create basically a map where such oil fields or combustion plants or so on are located, and then they just deactivate those pixels that are detecting those. And actually a lot of false positives can be caused also by solar panels or by water bodies or clouds reflecting radiation back to the satellite and basically looking like a fire from space. And what we do, in addition to what I already mentioned, is to also have a kind of a dynamic mask. So looking at the temporal evolution of the satellite pixels and see if the temporal evolution is realistic and actually looks like a true fire, or is totally unrealistic and cannot be a fire.
Okay, thanks, Yvonne. I got another one. How fast do fires spread?
So forest fires are slightly faster, or slightly, they are faster than what most of us probably run on average. So I don't know your running speed, but I think the average running speed of humans is about 6 miles. And the average running speed of a forest fire is rather like 7 miles per hour. But again, this depends highly on what kind of forest, how dry is it, and how strong, of course, is the wind. And interesting to know is that grass fire, so which is much smaller vegetation and often much drier, spreads a lot faster, and on average about 14 to 15 miles per hour, but it can be also much faster than that.
That's crazy. So Yvonne, I wanted to say thank you for joining us today. It was super informative and taking on this topic that's, not a fun one to face, obviously. So thank you.
Thank you. It's fun.
Great. I want to thank all of you guys for joining us and for participating. If we didn't get to your question, as I mentioned, someone will follow up with you afterwards, and the recording will be sent to you tomorrow. Like I said, please send in all the topics that you guys would like to hear about. Our favorite thing to do is these webinars, so we welcome it. And we will see you guys on the next event. Have a good one.
Bye.